I forgot that last time too. I'm going to put it on my title slide. I'm going to put a little note on the bottom that says, Patrick, remember to start the recording, just to make sure that I do that. Okay, so now we are recording, which is good. All right. So, so the news that we have so far. So first of all, a reminder that FlySet, which Fang Wang is on the in the meeting with us tonight, and she can talk about this a little bit more in a second. They have some grants that are available. Registration deadline is today if it's not already closed. And there's the URL: $250 grants for Dallas-Fort Worth area teams, particularly targeting teams that are in need of financial assistance, I think. And of course, you'll get assistance from 8565 Technipots, which is a really great team to be working with. So I would definitely do that. The next item that I have is that on August 22nd is the virtual workshop. And since Fang Wang is on the call, I'll let her jump in and say whatever she has to add about that's coming up.
Okay, thank you, Patrick. Do you have a schedule on your slides, or should I share my? Oh,
How's
yeah.
that?
Okay. Okay, so workshop is about 9 days away. We opened up individual registration this week. In the past, we have taken like team registration since it's virtual, so it's going to be individual one. So everyone who's going to join need to register to get a link. And this year we added the tracks for industry speakers. We have industry speakers talking about the sorting robot in the warehouse and robotics with AI. And we also have two college students talking about their robotics experience at college, continuing from high school. And Patrick's going to talk about the North Texas planning for next season. And then we have 4 tracks. There's the panel discussion about remote mentoring, remote training. There's a CAD track about introduction to Fusion 360. I saw Jerry ask resource for Fusion 360, so that will be a good one. And then in the afternoon, we have a beginner track and advanced track. And we kind of flip the hardware and software. So beginner track will start with software, and then advanced track will start with hardware. So that means if you're a builder, you could go to both way, one after the other. Okay, so the link is on the FlySet website, and you can click and register. Thank you.
Yep. So there's the link. Yeah, is this probably about the 4th workshop you all have done? Is that right?
The 5th or 6th.
5th one. Wow. 5th or 6th. That's really impressive. It's been a really good series. So we're really happy to see it continue on, even when we can't get together in person. All right. I also wanted to give people a heads up. So if you are a first team, a first team, but certainly a First Tech Challenge team in Texas, you should apply for these grants. Especially if you have if you have all high schoolers. Last year, it turned out they had money left over because not enough teams applied. And so it's an easy grant application. It doesn't take very long at all. And the grant application for First in Texas grants will open on August 31st. So put that on your calendar, be watching for it. Make sure to get your grant applications in. They've been doing it in 3 cycles. So that the first cycle would be on, they try to make awards in early to mid-September, then the next cycle again in October, and the next cycle in November if they follow the pattern that they've done in last year's. So definitely put that on your schedule. All right, so tonight, what I wanted to talk about, unless somebody interrupts me and says, hey, I really need to know about something else, is to walk through actually designing an FTC robot using Fusion 360. And I put in here episode 1 with a question mark because I'm going to run for about 90 minutes to 2 hours. I think after 90 minutes, people are just probably going to be tired. And so we'll go as far as we can with this tonight and see how far we get. And then there may be a second or even a third episode of this to take place in future meetings. They might not be on Thursday nights. I may just pre-record it and make it available, but just to kick things off, I thought I would start with that. So tonight we're going to look at Fusion 360 and what it would take to actually create an FTC robot in Fusion 360. I did a similar exercise with the team members on my team, and they came away feeling like, you know, they could do it. Now, of course, they've been using Fusion 360 a bit, but these are all the newer team members that didn't get a chance to do a lot of CAD last year, and so they're the ones who are going to be leading the CAD efforts this year. So Fusion 360, if you want to know how to get it, here's how I always do it. I do a Google search for Fusion 360 first, and let's see if I can pull up my Google page here and do that in Chrome. So if I just say Fusion 360 first, then the page that I usually find, first of all, is Fusion 360 for FIRST robotics competitions, and then I'll follow that particular link. And it'll go through, and it has enrollment, and there used to be a place here where you could register. If it's not there, it's probably the second link. Oh, FIRST Robotics, Autodesk, that's where I often would go. And it talks about the resources that are available for teams if you're doing FIRST Robotics. So there's free software, and there's the link here that says Get Fusion 360. So that's where I've always started, and I've been able to get Fusion 360 through there pretty quickly. They talk a lot about educational licenses and about having to be affiliated with an official educational institution, but as long as you list yourself as being a mentor for a team, my experience has been that you're able to get access if you're an adult and you're a mentor. If you list yourself as being a team member, then they're pretty good about being able to get access as well. The other thing that came up today in an email, I got an email from Rachel Moore. Rachel is another FIRST expert in North Texas. She has done a lot of FRC, but she's also been mentoring FTC. She's an FRC alumni. She's a Woody Flowers winner, if you know what the Woody Flowers Award is. And she said to really have remind teams or have people consider Onshape. And it's another CAD package, but it runs in a browser. And that's really exciting for me because I run Linux. And so in order for me to run Fusion 360, I have to start up a Windows virtual machine. And I always wonder how much slower that makes things. And so being able to run in a browser, and she even says it works on a Chromebook. So if you just have a Chromebook, if you're a team that mostly has Chromebooks, then you can do CAD models. And she pointed me to a couple of CAD models you can see in the picture there of an FRC robot that was done using Onshape. So just like I did the Google search before, if you go to Onshape first, then it will get you to a CAD package, and they call themselves the Google Docs of CAD. So all in the cloud, just use a browser and you can do some fancy CAD stuff. Rachel also mentioned that what really makes it valuable is they have already a huge parts library of robotics parts that teams typically need and use already in their CAD libraries. So you don't have to worry about downloading those or anything like that. So what I'm going to do is to get started, and we're going to work towards the robot design that is on the left. I've already built that robot, and I thought I would just do a quick video so you could see what it can do. So let me go to sharing that screen so that we can see it. I'll not share the computer sound though. And let's do that sharing. And let's try running this video, and you can see what that robot can do. It's a mecanum-based robot. And, well, I thought I wasn't sharing the sound. Maybe I am or not. It's a mecanum-based robot, which means that in addition to turning and going forwards, it can go sideways, and you can see it going sideways here. And you can see it's a little bit, you know, it's a little bit speedy. 7172 likes fast robots. So I showed this one to the team, and they're like, yeah, it's almost fast enough. It'll have to be faster. My goal for creating this robot was to come up with something that is entirely rev-based. So I wanted to come up with something that was entirely Rev Robotics based, or almost entirely Rev Robotics based, that was a mecanum drive that had some important features that I like to see in robot designs. At the FlySet workshop in a couple of weeks, I'm going to focus on the design aspects of that robot, what the things were, the principles that I was using to create that robot. Tonight, I'm going to show just the mechanics of how you might use Fusion 360 to put it together. So that's what we're going to be working on tonight. So with that, first of all, does anybody have any questions? Anybody have any comments before I go on? As I go through tonight, I'm going to stop frequently to invite comments and invite questions in.
Patrick, it's about educational license. It seems Fusion 360 now requires the students to submit some evidence document to show that you are part of the school.
That's probable or possible. What I would, what other organizations have accepted in the past is if you have a student ID, they would take a student ID, and or a report card would do it, right? So if you have a report card, you could blank out the grades, you can blank out some of the personal information, but most organizations that I've worked, such as the Texas Workforce Commission, has been just fine if you did a student ID or something like that. And certainly like a letter from a teacher would almost certainly work.
Do you know which, I think most high school is on the eligible list, but not all the middle school, like for Plano ISD, I know Robinson is not on the eligible list.
Probably. I don't. I wouldn't know how to fix that or what to do about that. But again, we did have one mentor this week who said that they were having trouble with getting the licensing that they needed. But they posted a couple of messages to the Autodesk forum and stuff, and I think it got taken care of, within a day. So
Okay.
so it can work. Or go use the other CAD programs that we just saw, right? And maybe that would work out as well. And we have a comment in the chat that where one of our students said they were able to get it with a student ID to get it.
Okay.
So yeah, I think Fusion, I think Autodesk, which is the maker of Fusion 360, I think they're locking down a little bit on the licenses because a lot of people have been using Fusion 360 for non-educational purposes through that educational license, and I think they're realizing that some people are taking advantage, so they needed to lock it down a little bit. Any other comments or questions? All right, well, if not, I'm going to switch over and share my screen to VMware, to Fusion 360. Hopefully y'all can see that okay. I tried to make the fonts a little bit bigger because I know it's going out over a Zoom channel and things like that. And so right now we're in Fusion 360. We're logged in under my account. What I'm going to do is just start through the process of what it would take to design a robot in here and start building it. So I've created a special project just for this series called FTC Clinic, where I'm going to do most of the work that I'm in and just start building robots and working on it from there. Across the top are the various tools that you would use, just like most word processors or other sorts of applications that you might have. In the middle is the canvas. This is where you do most of the work of designing the robot. Along the bottom are various tools to help you with the display of whatever the model looks like or whatever needs to be there. And on the very bottom is something called the timeline, which has the operations that you performed in order to create the model. So I'm going to just start with very simply starting with the two things that I think teams would need to know first, or designers would need to know to begin with in order to make use of Fusion 360 or something like that. So the first one is to be able to bring in parts for your model. And so I'm just going to go to Chrome here. And I'm just going to create a simple wheel and bearing assembly to start with to kind of illustrate all of that. So, of course, I'm going to be doing it based on Rev Robotics parts. So I'm going to go to the Rev Robotics website. And the first thing I'm going to do is to download a bearing block and show what we would do. So I'm going to go and say, okay, it's rotary motion, and it's going to be in the bearings and shafts section. So I'll go there, and I need to get several pieces here. So I need a bearing pillow block. And in the descriptions that are on the Rev Robotics website, if you scroll down towards the bottom, there's generally a CAD model, and the CAD models are held in things called step files. So if I just click on the step file, then it's going to download the step file into my folder. And actually, I have a bunch of stuff in there right now, so I'm going to clear out my downloads folder so I don't have to deal with all of that. And then we'll try it again. All right, so now I'm going to download the step file. And so it downloads that step file. And if I go back over to Fusion 360, you'll see there's a button here that says upload. So I can say upload, and I can go and select the step file that I just downloaded. So I'll go into downloads. There's the step file that I just downloaded. Open it up. Tell it to upload to Fusion 360. It starts uploading. What happens is the step file is going from my computer to my account in the Fusion 360 cloud, and their servers are then going to process that file into a format that Fusion 360 can handle. And so it now says it's complete. And you can see over here on the left is the file that I just uploaded, Rev 41 1317. If I open that file, then it'll open it up, and we can see here's the part. It's a bearing block. It's a bearing pillow block. Usually what I do at this point is I go ahead and rename the part so that I can find it more easily, because I don't have the Rev part numbers memorized. And if anybody does, anyway, I'm not going to say anything. So bearing pillow block. But I go ahead and leave the part number there so it's easy for me to find, right? So there I got a bearing pillow block. And to go along with the bearing pillow block, you also generally need a bearing. So I'm going to scroll down a little bit further here, and there's the bearing that I would need. So I'll go to that page and download it. So I downloaded that step file, and now I'll go back to Fusion 360 and upload that bearing. That's the step file there, and go through the same thing. You can upload multiple files at the same time. You don't have to do it one at a time like I'm doing here. And while it's working, you don't have to wait for it to finish. You can go and do other things while it's working. So while that's actually happening, I'm going to go get one or two more parts that I need for this demo. So I also need to have a hex shaft. So I'll download it. There, and I also need a wheel. So let's go back to motion. Oops, rotary motion would have been fine. Rotary motion, and I'm going to grab a wheel. Let's get a wheel, and I'm going to grab a 60mm Omni wheel and download it. And now I'll go back over to Fusion 360. I can go back to the upload button. I'm going to select the files. I just got both the shaft and the 60mm wheel. So I'm going to go ahead and get those uploading while I'm working on this other part. So that's how you download and get parts in for your model. Now there's a way to organize them. I'll show you the organization system that my team has been using for a bit, but right now it's easier if I just show all the parts over here. I'm going to close this window that I am in with the bearing pillow block, and I'm going to just start like I'm creating a new robot. All right, so here I'm in Untitled. This is a new robot. If you want to build a new robot, you actually need to save what you're working on before you can load any parts in it. You have to give it a name. So I'm going to save, and this is going to be example robot 1 here. And you can see it created example robot 1. And now once that's been created, we can bring parts into this model and start putting them together. So I'm going to start by bringing in the bearing pillow block and putting it into this model, and there it is. And when you first drop it in, You can turn it, you can replace it, you can move it in different places. So I'm going to turn it so it's upright, at least the way I think of it as being upright. And so you can see you've got these little handles that are here. So if you grab an arrow, you can move things up and down. If you grab one of these little uh, dots that are here, you can turn it in different ways. You can turn it that way, you can turn it around this way, and all the different axes. So you have a lot of different ways to be able to put it together. And then when you have it where you want, you just say okay, right? And so that has brought this bearing pillow block into my model as the first piece that I'm going to start with, right? So we've seen how to bring parts into Fusion 360. We've seen how to put them into our project. So now I'm going to add a bearing to this. So I'm just going to grab the bearing and pull it into my model, and you'll see that it puts the bearing in. And it likes to always put things in at the origin where things start, and they tend to overlap. So I'll usually just grab it and pull it off to the side. So the most important operation to know about and to be familiar with when you're trying to assemble a robot in Fusion 360 is the join operation. And that's how you join two things together. So I'm going to go to the join menu. It's under assemble. There's keyboard shortcuts for so many things. I'm going to try not to use the keyboard today so that you can follow what I'm doing and not just wonder, hey, how did that happen? So I'm going to start by creating a joint. And so a joint is a connection between two parts of your model, between two components. And so if I just click this and say joint, it opens up a little dialog window on the right. And that's asking me, what two things do I want to join? What is going to be component one and what is going to be component two? You always take the thing that you just added or the thing you want to join first, and then you pick what you want to join it to, right? So I want to join this bearing and leave this pillow block where it was. So I'm going to scroll around here. There's a lot of different controls for being able to move your model around, and I'm not going to go through all of them because there's tutorials and stuff for being able to do that. But I'm just going to scroll around to the bottom here, and I'm going to say I want to join. And not only do I say what I want to join, but I say where I want it to join. And I want to join that ring right there. And you can see how it's highlighted. You could choose the ring. I could say, no, I want to join this face. I could choose the cylinder barrel of the bearing, but I'm going to say join that little ring, right? And so once I've clicked on it, it now makes it grayed out because you can't join it to itself. And so now it's wondering, what are you wanting to join it to? And I want that ring that I just clicked and selected to match up with this hole in this pillow block. So I'm going to select that. And once I click those together, it puts them together. Now, unfortunately, it put them together backwards, right? So there's an option here in the dialog box called flip. And so it thinks it needed to be flipped, but I can just flip that and make it go the other way. And now the pillow block is, the bearing is joined with the pillow block as a single unit. So if I just hit OK, and now I can move it around, and if I grab the bearing, then you'll see that it moves it together because they're joined together, right? So that's the very common operation that we'll be working with throughout this. You can also see just very faintly, there's a little marker right in the middle. That's the marker that represents a rigid joint. And what it's saying is this is where these two things are joined together. So I can go and edit that, and there's lots of ways to edit the joints. I can look at that. If we look at the timeline, we can see that we've done 3 steps so far. So one step is that we inserted a component, a bearing pillow block, and then we inserted this part, Rev 411329, which is that, and then we joined them together in a rigid joint. I can go back and edit that joint, and I can say, I want it to change the motion. I want to change the type of joint that's there. There's lots of choices. So it can be rigid, it can be a revolution, it can be a slider, it can be cylindrical, it can be a pin slot mechanism, it can be planar joint, or it can be completely free in a ball joint. So I'm going to change this to be a revolution joint. And watch what happens with the bearing when I make that change, right? If you can see that it's now turning, and that represents that the type of joint between these two objects is now a revolution joint, which means that Fusion 360 knows that the bearing is able to turn within the pillow block, right? So now we can model that. We can move it by hand. So if I try and grab it, what happens is we do this, because the pillow block tends to want to come with it. I'm going to ground the pillow block. I'll talk about that a little bit more later. But I'm going to ground the pillow block, which means I don't want the pillow block to move anymore. The pillow block, if I grab it, I can't move it anymore. It's fixed. It's grounded in the system. But with the bearing, because it has a revolution joint, I can still make it turn. I can make it turn by hand just with my mouse here to be able to see what the impact is. Whenever you move something around, there's a little thing that notes that the position has changed. And you have an option whenever you change the position. So I could just be playing around with this. So one option is I want to capture that and say I want it to take that new position. Or the other one is I want to revert back to where it was before I started fiddling with it. So I'm going to revert, and you'll see that the bearing will pop back to its original orientation. So I'm going to stop there and open up to see if anybody has any questions. Am I going too fast? Good enough? Too slow? You can put it in the chat. You can put it in the you can put it in the chat if you have a question, and I'll try and see about that. But okay, Scott says going great so far. I'm going to continue on. All right, so now the next thing I'm going to do is put a shaft into this pillow block. So I can go over. I downloaded the shaft already. I'll pull it across. You can see there's the shaft, and I'm going to kind of move it out of the way. And so now what I want to do is connect the shaft to the pillow block. So I'm going to do the same sort of operation that I just did before. I'm going to say joint. I'm going to grab, you'll notice the pillow block is grayed out. It can't be joined to anything because it's grounded. It's fixed, so you can't make it move anywhere. So I'm going to grab the end of this shaft. And as I scroll in, as I get on that face, you see all those little dots there. Those are all of the snap points. Those are the places that can be joined to. So I could say, I want to join that little tiny corner there, or I can join the center of that face, or I can join the center of that edge. I can join that edge. I can join this face. You can pick where you want to join. I'm going to join right on the end of that face, and I want to attach it to this pillow block, that center point on that face. Now this one becomes tricky. So the lesson to learn here is the control key is your friend. I meant to get a keyboard display so that you could see what keys I was pressing when I do special control keys, but I didn't have time to get that. So I'm highlighting this face right now, and I really want to join the center of that shaft to that center point. But as soon as I move off the face, it says, oh, you're wanting to go somewhere else. And I don't want to join to the center of that face. I want to join to the center of this round face on the end. So once it's highlighted, if I hold down the control key, so right now I'm holding down the control key on my keyboard, no matter where I go with the mouse, it keeps that face highlighted. And now I can get and select the point that I want to join to. So now I can say join with that. And so it joins the shaft there, and it's a rigid joint. And we can see that it's made, you know, that particular, that connection there between the shaft and the bearing block. Now, I really want the shaft to go through the bearing block, so I'm going to flip it around. And we can see that when it joined, they're out of phase with each other. They're not exactly fitting together snugly because they're about 30 degrees rotated. With round shafts, you don't have to worry about that, but with hex shafts, you kind of do. So once again, like we did when we first placed a component, you can turn it. And I'm just going to turn it 30 degrees so that it will fit correctly within that bearing. The other thing is that I probably want it to extend away from the bearing, so I'm just going to pull it through. If we scroll out, you can see what I'm doing is I'm moving the shaft through the bearing just as if I was assembling it by hand. And I'm just going to put it in the middle there. And then I'll hit OK. And now the shaft and the bearing are joined together. And in fact, if we watch really carefully, when I move the bearing, you'll see that the shaft will turn with it. if I can select it, there we go. When I move the bearing, the shaft is now turning with it because they're fixed together. So they're both turning around that revolute joint that the bearing had. All right, let's add one more component just to show more of how this works. Let's add a wheel onto the shaft. And let's move that out of the way. So I'll say, okay. This wheel's a little tricky. So Rev has been really nice that the Omni wheel that we have here comes in and they actually have modeled all the different parts. But the step files don't always know the joints that are there. So if I try and grab this, what you'll see is that what I think will happen is you'll see, oh no, it's all together. Okay, good. I don't have to worry about it on this one. We'll see some models. Sometimes when you bring in a model, if you grab one of these wheels, it comes away from the rest of the model because they're not joined together, but it seems to know about these joints, so that's good. So I'm gonna put this wheel onto the shaft. It's the same thing as before. So I'm gonna do a joint. It says some things have been moved, so I'm gonna say just continue, let it be back where it started. Once again, I'm gonna select this face to get to that little center point, and I'm holding down the control key. And then I'm going to connect it to the bearing. I'm going to connect it to the bearing just like I had before. And rather than try and catch that center point that's there, I'm going to connect it to the outer ring. And so I'll select that. And oops, oh, it wants to know where to connect it to. I want to connect it to that little spot there. And if we scroll around here, we can see that the wheel, the hub of the wheel is directly against the face of the bearing because I picked that outer circle to do it. Let's try a couple of different spots just to see different things that would happen. So I'm gonna cancel where I wanted to connect it to. And now it's asking me, so I'm gonna choose this circle instead. So if I connect it to that circle and we go around and see, you'll see that it connected the wheel to the back of the flange of the bearing. And so the hub is now actually inside the bearing. That's physically not possible, but the model doesn't care. It just, all I'm showing is that it depends on which circle you click as to what face it will actually connect to. I'm gonna go back and fix this. Again, so I'm selecting the outer face and then I go to that outer ring and I'm saying, make those two connect together and line up on that center point. And it does it for me. So now they're connected and we're good to go. And since all of those components are rigid with each other, when I move the wheel, you can see that it turns with the shaft and the bearing inside of that pillow block. Any questions on there? I see a question about somebody that's trying to about trying to drag the parts into the plan. So if you start a new project or if you start a new component and you don't have it saved and you try and drag something in there, it won't let you do it, right? It'll give you this error. Please save this design before inserting components. So that may be the problem that's being seen there. And to add the component, there's two ways to add it. If you double click it, it will open it up. It will open up that component. If you right click it, so I'll right click, you can select insert into current design, or you can do as I typically do and just drag it in place. All right. Okay. Any other questions or comments? I hear somebody unmuted, so. All right. So let's go back up to the top level and I'm going to create a new folder and I'm going to call this 0813 Rev Mech Chassis. I'm going to space it out because that looked really weird. Mech Chassis. And now we're going to see about actually creating a drivetrain, something a little bit more substantial than this. Oh, by the way, don't forget to save, like, you know, save whatever you're wanting to do. Save often in Fusion 360 because it does keep a history. So if you make some changes and you decide you don't like them, it's easy to revert back to an earlier version. So I just created a folder. I'm gonna go into that folder And I'm going to start a whole new design. I think I'll leave that open just in case we need it. I'm going to start a whole new design, and this is going to be called our drivetrain. Right, so I've just started an empty project here, and this is where most robots would begin. Let me go back. Actually, I'll go back to the example. You can see on the bottom, the timeline. These are all the steps that we did. So we inserted a component. We inserted another component. We joined them together with a revolution joint. Then we ground the pillow block so that it couldn't move. Then we added another component, the axle, the shaft, and we joined it. And then we added the wheel and we joined it. That's the timeline of steps that are done. You can walk through the timeline, so I can back up in the timeline to see the impact that each step had on the model. And you can also get rid of individual steps out of the timeline or insert things in the middle of the timeline if you need to. On the left up here is the browser. And the browser shows you all the components and things that are part of your model. So here are the components that we added: the bearing pillow block, the bearing, the shaft, and the omni wheel are all there. And also here are the joints that we created. We created a revolution joint, a rigid joint, another rigid joint. And so if you just click on the little arrows, it'll expand out to show you everything that's in each of these different components so that you can do things. All right, and I bring that up because for the new one that we're creating, I'm going to start by creating a new component and building things within it. And I just do new component, hit OK, and it comes back and says, here's a new component. Then I'm going to single click on the name, and that will let me rename it. And so this is going to be side 1. So this is going to be a place for one side of my robot. And I'm going to make it as a separate component because I'm going to copy it over later to make the other side of the robot to try and make it quicker. So now when I'm inserting parts, it not only goes into my model, which is called drivetrain, but it's going to go inside of this little component that's called side 1. We'll see that here in a second. So the first place I'm going to start with the robot is with a piece of extrusion. So I usually keep a parts folder where I keep all of the parts that I've downloaded or that are reusable for the different models. We've done this on 71, 72, and it makes it easy because everybody knows where to go look for parts that they're going to load into the robot. You'll see that I've also put these numbers in front: 00-parts, 99-work. Those are sort criteria. So if I change my sorting criteria, oops, wrong button. If I change my sorting criteria and say sort by name, then parts, because it begins with 2 zeros, will always show up at the top of the list. And 99 work will tend to show at the bottom. In fact, I should probably change it to be 99999, so it'll show up at the bottom. So we just use the numbers to kind of be able to order things without having to worry about naming them alphabetically. So if I go in the parts window, we've decided to pretty much copy the rev hierarchy for how things go. Most of the other robotics companies tend to use a very similar hierarchy. So we have a folder where we keep all the bearings and shafts, and we have another folder for electrical parts, another one for hubs and sprockets. So extrusion will be structure. So I'm going to go in and grab a piece of extrusion, and I want this 420 millimeter extrusion. So I'm just going to pull it into my model. And when I do that, I'm going to rotate it so it's running that way. And so this is going to be the left side of my robot. You can see that I have it going this way. The orientation that we have is up in this upper right-hand corner. You can see that the top is pointing upward right now. Front is facing towards the bottom left of the screen, and the right side of the model, which is the left side of the robot, is facing towards the bottom right of the screen. So I've just pulled it in there, flipped this around that way, and I'll say okay. And now I have this nice long piece of extrusion that is going to be on that side of the robot. And I'm going to go ahead and ground it as well. So I'm going to expand this out. We can see here's the extrusion that we just put in. I'm going to right click on it and I'm going to say ground and fix that in place because every other part of my robot's going to be relative to this one. All right, the next thing that I need is to be able to have a bracket to begin to create the place where my wheels are going to go. The first part that I'm going to work on is just getting wheels on the robot. So I need a bracket, and this gets into design, and I'll talk more about design in the FlySet workshop about how I came up with these specific ones. But I ended up choosing the indexable motion bracket, which I don't have loaded. So let me go grab it from the Rev site real quick. So structure, it's a plastic bracket. When designing this robot, I wanted to try and stick with parts that were in the starter kit so that more people would be able to build the robot and not have to buy a bunch of special parts. So the indexable motion bracket is one of those parts. And so it has the feature that is the most important feature for my purposes is that it gets the shaft as far away from the extrusion as you can get, because I need room for the wheels. So it allows you to get to the center of the shaft about 32 millimeters from the center of the extrusion, which is big enough to get that makes it big enough to get a what's the word? A mecanum wheel below the top of the shaft. Guido has a question if you can shorten the extrusion. Yes, you can. And I have a special way of doing that. I don't know if I'll get to it today, but I will show an example of that either today or in the next episode. But yes, you can shorten the extrusion. I can. Let me do the not brackets. Let me do the quick example. I create a special extrusion. Let's just go back into the example robot and I'll pull it in there. I create a special extrusion that defaults to 100 millimeters. So I'll pull it in and pull it here to the side. And I'll show how this was created probably before the end of tonight, I think. So that's a 100 millimeter extrusion. You can see it was pulled in there. Right now it's linked back to the original file. There's a way that you can break the link. And when I break the link, what happens is this model that we're working on right now gets its own copy of that component, as opposed to being simply a reference to this other one. And by having my own copy of that component, now I can modify it pretty easily. So on the timeline at the bottom, let me undo that step. So I'm going to undo the break link. Here's where I inserted the component, right? And you can see it's got a little link on it, and that means it's linked to another model. So I can't make any real changes here to the model. But by breaking the link, right, now that got converted into a group. And if I press this little plus sign, these are the 3 steps that were used to make this part. So one step was create a new component. The next step was a sketch, which is the shape of the end of the extrusion. And the third one is an extrude step that says how far to pull it. And so I can edit that and I can change the extrusion length from 100 to be some other length. Like let's say we need 225. So I just switched it to be 225 millimeters and that made it longer. Or I can even drag it out to make it as long or as short as I want. So that's the way that on 7172 we've been making our extrusions. Is we just have a standard one that we can pull into the model, we break the link, and then we can extend or shorten it to be whatever length we want when we're putting it into the model. So that's the short version of it. But I'm going to stick with the 420 because that's what comes in the starter kit. I do need to go load in the indexable motion bracket. Let me just rename this. Indexable motion bracket. So it's easy to do. I'm going to pull it into my model so I get a copy of the model. Now, the way that the indexable motion bracket works is it's actually 2 pieces, right? So this one piece here is on the back, and I'll pull it away for a second. And it's the part that really attaches to the extrusion to be held in place. And you can see it's got this little bump ridge in it in the middle, and that's to go inside of the slot of the extrusion. And on the other side of that little tiny bracket, it's got this fan, this little grid here, this rack that's there, and you put it somewhere on the other bracket, and those pieces lock in place with each other to keep it from moving up and down. The indexable motion bracket it's kind of a, it's not necessarily a super reliable part if you're not careful about it. So I don't know that very many people end up using it, but the starter kits always have them. And so it was an easy place to start to be able to do things. And the key thing that I needed is that it allows me to get the center of the shaft as far away from the extrusion as I possibly can. It's the bracket that Rev has in their starter kit that gets you the farthest away so you can maybe fit a wheel underneath. So the first thing I want to do is I'm going to join this piece to this one to make them a unit at its maximum extension, so I don't have to keep doing that. So in order to join them, I need to break this link. I need to break that link so that I have my own copy of it in this model. And I'm going to do the join, and I'm going to say joint, and I want to join this circle right there, and I'm holding down the control key again to be able to get to that part. So I'm going to join that circle with this circle here, right? And it's going to look a little weird at first. You're going to say, oh, you put it on the wrong side. Yes, I did put it on the wrong side. I did it on purpose, right? But you can see it took that circle that I had highlighted and joined it to that other circle. Now, so that way I know it's at its maximum extension to the top, right? And so now I can say, I want to move it this way, and I'm going to move it so that it's exactly snapped into place on the model. I could try and figure out exactly where that is. I could guess that it's probably 3. There's a really quick way to do it. So I'm going to move it way over here. I have this arrow highlighted. So if I pick a face that is normal to that arrow, then it will line it up with that face. So I'm going to snap on this face of this other bracket, and you'll see it snaps it to exactly in place so that they are aligned up perfectly. And so now when I hit OK, those two components are joined together and they'll move as a unit. And that's pretty nice because I'll be able to reuse this later on. Any questions about that so far? This is a good place to break for questions before I do the next step, plus I can get a drink of water. Or any comments? Is anybody having fun? How did I snap it? Okay, so let me undo. I'll undo the joint. Okay, so in order to snap this together, what I did is I went and said joint, and I went on the little tiny bracket that's in there. I highlighted this face. I could also highlight this little edge here. I'm trying to get the center of that hole, right? I'm really, actually, it looks like I could almost do the center of that hole that way too. But when I highlight something that puts a snap point on the thing I really want, then I hold down the control key, and now I can move my mouse around. Oops, cancel that. Now I can move my mouse around to get that exact point. When I've got the mouse highlighting that exact point, I click on it, and that says that's my join point. That's my first join point, which is the center of that circle. And now my second one is going to be up on the bracket, and I'm going to choose, there's a little plus sign right in there, and I want to choose it and make those two snap together. And now, because it's on the wrong side, I want to use this arrow to move it back and forth. And when that arrow is highlighted, meaning that's what I'm currently doing, I can click on this face and say, line it up with that. And so it lines up with that, and now we're good to go. All right. So that's now together. It's now together as a unit. I'm going to revert back to where it was. Now we need to attach this to the extrusion. If you are doing actibiotics, it's really easy to attach holes to holes. If you were doing Tetrix, it's really easy to attach holes to holes. If you're doing GoBuilda, it's really easy to attach holes to holes. If you're doing Rev, it's really hard to attach a hole to a slot. There's not really anything to like grab onto. So after a day or two of experimentation, this is the way I came up with. There are many ways to do it. And I'm going to go turn off my joints here real quick. So I'm going to go to object visibility. See that little joint symbol there? As you get more joints, they start cluttering things up and getting in the way. So I'm just going to say, don't show me the joints for now. I know they're there. All right, so the way that I found to do it is, what I'm really wanting to do is, let's get this closer together so that we can see what's going to happen here. What I'm really wanting to do is to be able to attach this bracket into this slot that's right here. But there's not really anything, you know, that I can attach to easily without doing some weird calculations and the like. And I don't want to try and attach the middle of this face. I don't want to attach the middle of that to the back of the slot, because that's actually too deep inside of the extrusion. In reality, what I know will happen is that when these are attached in the real world, is that this face will be flush with this side of the extrusion. So that's really what I'm kind of wanting to attach somehow. But I don't have the proper things to be able to do it quickly. If anybody finds a faster or better way to do this, let me know someday. But what I'm going to do is I'm going to do another join, much like we did before. And I'm going to say continue. It's going to move that piece way far away because I didn't want to capture the position. And I'm going to say, I'm going to grab this hole, just like I did before. I want to attach that hole right there. And I'm going to go up to the bracket, to the extrusion, sorry. And I'm going to attach it to the back of this face. So this is the inside face of the extrusion. And there's a snap point way down in the center of the extrusion, but I'm going to grab the middle of that face, and I'm going to say, attach that point of that bracket that I just gave, attach it there. And you can see those two are now attached. The center of that hole is attached to the edge of that one face. It's not exactly in the right orientation, so let's turn it around a bit here. So I'm just going to turn it 90 degrees. So now it's in the correct orientation, but it's attached way at the back of the bracket. I want it to be flush with this outer edge. So I'm going to grab that arrow and say, make it flush with this outer edge, and boom, now it's flush with the outer edge. And I can pull it to the right to make it part of the extrusion. And now that bracket has been attached to this extrusion exactly in the right spot. You can see if we look really closely inside there that the little tabs that are on the bracket are nested inside of the slot, which is what you would expect to happen. It's flush against the face of the extrusion and so forth. So I'm going to end up doing this a couple of more times in the demo. So I'm not going to repeat it now, but I'll go through it slow again when we do that. And when I hit OK, this accordion piece will be attached to this extrusion. And since the bracket was attached to the accordion piece, it will snap to it as well, like so. Right? And so now that bracket has been attached to the extrusion and it's fixed in place. I can't move it. Any questions or comments on that?
So Patrick, how do you so it's in there? So is there a way in which you know the distance that you are, the placement that you are on the extrusion? Like how many
Down the
inches
length
or
of the
millimeters?
slide?
Yeah.
Yeah, I did that a little fast, so I'm going to go back and edit that joint, right?
Okay.
And so here are our arrows, and over here on the right is the distances, offset
Okay.
X, Y, and Z. And so my Z is this one, and it says I'm 5.5 millimeters offset in the Z direction from that point that I had started with when I did the join. I'm not offset anything in the X direction, which is down this way. And in this particular piece's Y direction, if I click that, it says I'm 32 millimeters away from the end of the thing, of the extrusion. So if I wanted to be exactly 50 millimeters away, then I can type in 50. Or if I want to go 40, I'm going to go 40. 40, is that going to be enough? If not, we can move it later. All right. But does that answer your question?
That does, and it's measuring from the center hole. Is that correct?
It's measuring from the join point, right? So
Okay.
my join point, it's the distance that was from, I'm gonna hide the extrusion real quick, right? So I said to join this hole, the center of that hole, with that point on the extrusion, the middle of that. And so all the distances are from there, between those 2 points in the X, Y, and Z directions.
Perfect.
And just because I like to, a lot of times when the parts come in, they all get treated and colored as if they're aluminum. I'm going to change the appearance of this bracket. So I'm going to go to appearance. Sorry, that was a little fast. Let me close. So under the modify menu, this is where you can modify components in different ways. I'm going to go to appearance, and there's a bunch of built-in appearances in Fusion 360. I'm just going to grab paint because it's quick. I'm going to go to glossy. I'm going to say, just paint this object black. And so I'm going to grab that little paint ball and I'm going to drag it onto the motion bracket, and it will turn it black. Right, and so now it's going to be easier to distinguish the two parts together. Okay, so I've added an indexable motion bracket. For my model, I'm going to need another rail on the other side to hold the other end of the axle. So let's go ahead and put another extrusion over on the other side. But
Patrick,
I'm going to do
before
it.
you go on, I'm
Yes.
sorry.
No,
what
no
if
problem.
you realize that you connected these, but the bracket is pointing down and you wanted it to point up? Is there a way to change the orientation after you've made this joint?
So you can always go back and edit the joint. And you see the little turn thing?
Yeah.
I can turn it the other way, like so, and say, and I'll probably would need to move it back or something like that, and say, okay, and there you go.
Nice. Okay, thanks.
Sure. And I just hit undo for everybody wondering, hey, how do you flip it back? I just hit undo. Okay, so next I'm going to want to put another extrusion over on the side. There are a bunch of different brackets that Rev has available, but I have quickly become a fan of their C channel. So let me go to structure. Let's see if I have their C channel in. I do not have the one I need, so I'm going to go grab it. I only left the first few parts unloaded just so people could see that work. Later on, the parts we need are all pretty much loaded. So we won't be spending too much time downloading parts. So these are the C channels. These are new for Rev. They just came out for the upcoming season. They're kind of, they're kind of like extrusion matched with plates, but they're thin and they're strong because they are C channels and they have these right angles. They're actually reasonably strong for being able to put pieces together. So I'm going to go back into Fusion and I'm going to say upload that for me there. And so it's currently uploading. And the reason I like the C channels is because if you've ever built with the Rev parts and the extrusions, then what you will discover is that because the fasteners can slide along the rails, you have to work a little bit to get things to be square. It's really easy to build a robot that isn't square, and that's not always what you want for your robot, especially for wheels and things like that. The C channel is a really nice, small, lightweight piece that can go onto the robot and can help make sure that you keep things square. Now 7172, because we didn't have C channels before and because we have the ability to create our own plates, we would create our own endcap plates to do this for us. But now that Rev has these C channel things, we can just do it with those. So that's pretty nice. So again, it's another join. So I'm going to join this part here, I'm going to grab the edge of the circle, because what I want to do, actually, let me stop sharing real quick and just kind of show what we're getting towards on the screen, also just to let people see it here. All right. So what we're getting to is we're getting to something like this, right? And so we have the two rails that are there, and the channel is on the end, and it's going to hold these two rails at a fixed distance apart, and they aren't going to want to move. And then we have the brackets on the end there for us to be able to put a shaft through. So that's what we're working towards in this CAD model. Okay, so with that, let me go back to sharing. Okay, so I'm going to attach this piece of channel here, and just like I've done before, I'm going to go grab the middle of that hole that's right there. Actually, I could just grab this one, I suppose. I'll just grab that one. I like that one better now that I think about it. My other one, I did it there, but I'm going to grab that one. And like I did before, I'm going to attach it to the bottom of this back face right in the middle there. And it's going to come over, and there we can see that it's attached. I need to turn it 90 degrees so that it's that way. I need to bring it up so that it is flush with the top of the extrusion. And now I can move it back so that it's somewhere, and I'm going to go ahead and move it back here somewhere. Right, and so now those are attached together. And most importantly for this, and the reason we do it that way, we want to make sure those holes are lined up with that slot, because that's what's going to really happen when we build it for real. We don't want to have it where we just put them and attach them together, but the holes are actually not in alignment with the slot in our model, because then it won't fit when we try and build it in real life. So that got me this one there. Depending on how much you want to model, you could put all of the screws into your model, right? Like we could actually put the screws in here where they're actually going to go in the model. What I do for my models and what 7172 tends to do is we only put the screws in where clearance is likely to be an issue. And we will have that happen on this particular model. So if clearance is likely to be an issue, we go ahead and put the screws in just to make sure that we get appropriate clearance on our model. So now that I have this one, I'm going to add another extrusion over on the other end of this bracket so that it would be connected there. I could, of course, drag another one in, but one nice feature about Fusion 360 is once you've loaded a part into your model, you can just copy and paste it to get another part. So all I'm doing is right-clicking on this extrusion, hitting copy, and then I'm going to right-click on the background and hit paste, and it's going to paste another copy of the extrusion in. And just as if I dragged it in, I can pull it over, and now I can do the attachment. So now I need to attach this rev rail to the holes that are here. So this is kind of the opposite sort of step as before. I'm going to go and say, do a join. And I'm going to say, grab the middle of the bottom of this back face, grab that point, and I'm going to go join it to the center circle that is here. And so that brings them together, but it's up too high. So I need to lower it down. There's not anything I can make it even with easily. So I actually have to type in the number here. I have to actually say 5.5 millimeters. And I know that it's 5.5 millimeters because I've measured it before and I've done it so many times. And you could always figure it out on the model. And then I want the front of this extrusion to line up with the end of this extrusion. So I'm going to change this arrow, which controls how much it goes back and forth. And then I'm going to click on the end of this other extrusion and say line that up with that. And now they're both aligned up together so that I know that they're lined up properly. All right, so that's one way to do the join. There's another one which I'll probably show for another join in a second. At this point, things can start going quicker because my parts that I need are in the model. So now that I have this rail and they're fixed all together in place, I need to copy this bracket over to this side. So I have my other bracket. So I can just copy this indexable motion bracket. By copying this one, it's already got those two pieces joined together like we had before. So I don't have to worry about repeating that join that I did when it first came in. So I copied it. It says, here it is. And now I'll just repeat the joins that we've been doing. But for this join, I'm going to cheat a little bit, or at least I think of it as cheating, but it kind of works. Rather than attach the bracket to the extrusion, I'm going to attach this bracket to this one. So I'm going to take and say join this bracket. I'm going to join this hole right there, the one where the bearing would go in, or the other piece would go in. I'm going to join that hole to this hole right here. All right, and they'll go right on top of each other, and now I can move it back and forth. By doing it that way, what I'm certain of is that these brackets will line up, and that's important. That is the important thing about these brackets, is you want those holes to be aligned with each other, because there's going to be a shaft and some bearings going through. You don't want them to kink. So I went ahead and aligned this bracket. Oops, not that one, not that one. I aligned that bracket, the center, the borehole, in the middle to this other borehole in this bracket. And now I'll just move it back and forth and say, make that flush with the extrusion. And now it's there flush with the extrusion. Some people are probably wondering and saying, wait, shouldn't it go on the other side of the extrusion? Yes, you could model it that way, but mine is being modeled on the same side because the shafts that I have won't reach if I put it on the other side. So the model I have does it this way. All right, and so now I say okay, and there we go. And so I've now added that other index bracket. Okay, so next it's time to put the shaft in there. I'm doing a dead axle for this model, and I'll very briefly, I'm going to stop sharing the CAD window. Actually, I'm going to stop and ask if there's any questions while I get this next part ready. And there's a couple of questions. Yeah, okay, got it. Okay, I already answered that question. All right, so here's basically what we have right now. All right, so this is the model that we have. It's got a channel holding it together. It's got the indexable motion brackets that are there. And typically, the way that Rev would have you use their various brackets is you take a shaft, you put a collar on the end of the shaft, you put a bearing on that, and you put it through one of these holes, and then you attach a wheel or whatever else you want to attach there. And then you have, and it goes through the other hole all the way through. And then you have another bearing on this side and a collar on the other side, right? And that's what we would typically call a live axle. I'm not going to tighten it in place, but this will be good enough to be able to see how it works, right? That's a live axle. It's a live axle because the axle spins with the wheel. As the wheel turns, the axle turns. So if your driving force turns the axle, then that causes the wheel to turn. But we found that we didn't like that very much with some of our robots for this very specific reason. So I'm going to pull all of this out. These brackets are really wobbly, right? So if I just push on this bracket, you can see how much wobble it has by pushing on it. If I push on the other side, then I can do it. And it's really dramatic when you look at it from the side. So if I push on this bracket, wow, right? And same thing for the other side. So when the shaft is in there, and you put your bearings in place and you have your collar on the end, everything looks good. But if there's any sort of force, I mean, it can wobble a fair distance here. And if there's any sort of force on the brackets, then they can actually come loose from the bearing, right? So the brackets, you know, aren't this is a problem that many teams have noticed, that their bearings will come off out of the brackets because the brackets can bend. So now you have to figure out, what are you going to do to fix that? You could double up the brackets, but that takes up space. You could try using metal, but the metal brackets don't have the same features that the plastic ones do, and they cost more. For my team, for 7172, we cut our own plastic parts. And so the plastic parts that we create with the CNC mill also have this bending characteristic that we don't want. So instead, what we do is we create what's called a dead axle. And so with a dead axle, which is on the other side of this, that's there. With a dead axle, we actually have hubs on either side of the brackets, and they clamp the axle between them. There's a set screw on these hubs, and you can kind of see the set screw hole here. You can see the set screw hole, it's kind of pointing upward to make it easy. And so this axle is fixed. It won't spin in place because the hubs are fixed and they're clamped on the axle. But the end result of that in terms of strength is amazingly strong, because you saw how much I could bend these guys when I had that axle in. But with this one, I can't barely move them at all. I mean, I'm like really pushing on this, and they are not wanting to bend at all. And same thing for the other side. Right? And on the other side, it's even harder. It just really does not want to move. So this is a really strong structure, considering that you just have this pair of plastic brackets that are there and the hubs that are there. So my team has gotten to where we really like the dead axles for doing that. The challenge to the dead axle is it doesn't spin. Right? So now, how do you make the wheels turn? You can't just use a standard rev wheel as is. Let's go overhead again. It's a little bit easier to see. Can't just use a standard rev wheel because it's got the hex pattern that's not going to let it turn. And that's okay. We don't want to use rev wheels anyway. We want to use mecanum wheels. So with the mecanum wheel, we can kind of do it. There's a hole there, but now we need some way to be able to attach with bearings so that the wheel will spin around the axle. Where's my axle here? So we need some sort of bearing structure that allows this wheel to turn even when the axle does not. I chatted with Rev Tech Support earlier in the spring as I was trying to put this model together and come up with it and so forth. And ultimately what we decided is we needed a 3D printed piece to do it. We needed a custom piece to do it. And so what I came up with is essentially this. And here's one without the bearings in it. Right, so this is a 3D printed piece. I will go through, it's already 8:15, so I don't know if I'll get to it tonight, but it'll be the next session, how you model this piece in Fusion 360 and the process for creating this piece. But the idea is that this acts as a spacer. You need a spacer because when you're putting it onto your mecanum wheel, the chain has to be away from the wheel. So we needed a spacer to get the sprocket, and by a chain turning the sprocket, the wheel is now able to turn even though the axle is not turning. And I don't know if you can tell that the axle's not turning, but I'm holding the axle fixed and the wheel is turning even though the axle is not. So that's the kind of the goal with a dead axle, is that you have a sprocket or your driving force connected directly to the wheel and not relying on the axle to transmit the torque to the wheel. And so this spacer does it. So the parts for the spacer that are needed is we have a spacer, and inside of the spacer, I bought a couple of bearings. You can't get these bearings from Rev, so this is the one component of this model that does not come from Rev Robotics besides the 3D printed piece. And it's designed to press fit into a little hole here, which I hope I can get it to fit. My 3D printed piece might not have worked out quite right, but it's designed to press fit into there. And so if you just press it in place, now this little thing has a bearing in it, and there's a place for the bearing to go on the other side as well. And then Rev also sells these little inserts that go into an 8mm bearing, which is what this is. This little plastic insert gives a hex pattern into the bearing. So if I push this little hex insert in place, then now I've created this bearing structure so that when I put it on a shaft like so, the this little spacer piece can rotate freely around it. And if you have a bearing on either side, it's going to be well supported. And then you attach the wheel to this spacer with the bearings in it, and the wheel will spin around. And it spins really well. So like, here's the wheel that I have, and I'll just start it spinning and let it go. And you'll see that it likes to spin for a while. There's not a lot of friction there before it comes to a stop. So that's kind of the goal of where to get to. So the next part of this model is just going to be setting up the dead axle. Any questions on that before I go on?
So Patrick, where'd you buy the bearings?
Amazon. It's the only place to buy anything if you're not getting it from a robotics part. So just a minute, I'll show you where I got it from Amazon. Oh, actually, I can just do it this way. It's faster. I don't have to share screen for this. Come on, Amazon. Oh, wrong one. Amazon. So yeah, Amazon. So well, and let me. I'll probably talk a little bit more about it for a bit. But this is an 8mm inner diameter by 12mm outer diameter by 3.5mm bearing. And so you go there and you go to Amazon, and you can see there's one here right up front, pack of 10 for $10, delivered to my house by Saturday. So, you know, they're in stock, they're easy to get to, and so forth. As I said, Rev has bearings, and they're really good bearings too. I like the Rev Robotics bearings. The one feature that the Rev Robotics, or misfeature for this purpose, that prevented me from using the Rev Robotics bearings is that they're flanged. So let's see, where's the Rev Robotics flanged bearing? Well, let's just do a search and see where I get to. Next page. There it is. So Rev has also the 8x12 by 3.5mm flanged bearing, and I wanted to bring a flanged bearing with me, but the Rev flanged bearing has the little flange on it that keeps it from going inside of a channel, inside of a 12mm hole. And the problem that I ran into with that, if I tried to use the Rev bearing, is that the flange would then block the screw holes that I needed to attach the wheel or to attach the sprocket. The flange was just too big and it got in the way of the screw holes. So I needed something to get rid of the flange. Fortunately, Amazon came through with a quick answer for that. Good question. Thanks for reminding me about that. Okay. So, and we'll see all that when I go through and model the, not that one, that one. All right. When I model the thing. All right. So the next piece is to put the shaft across here. So I'm going to do that pretty quickly. Somebody stop me and just say, slow down, back up if I go too fast on this part. Rev also came out with relatively recently. It's been out for a little while. A new hub that I really like to use. So if I go to rotary motion and we go to hubs and adapters, and there's the picture of the one I want. It's the locking motion hub. So it's like the other hubs, but it has a set screw so that you can lock it to a shaft. And that ends up being pretty much what we want. So I'm going to download its step file real quick because I don't think I have it in Fusion 360 already. I'll go up to my parts folder and I'll go to hubs. And I will say upload into my hubs folder. I'm going to grab that step file that I just did and say upload, and it'll pull it in. And it's busy doing its analysis. And once it's pulled in, I can pull it into my model. And there it is. All right, so I'm gonna go and attach it. This time I'm gonna try and be a little, actually I think I'll just do the same way I did before. So I'm gonna try and attach that inner circle of this hub to this outer circle of this bracket. So I will say assemble, join. I'll go down to this little piece here. I'll grab that circle. And I'll attach it to that little outer circle, and it pulls it up, which is really nice. This is a good point to remind teams and team members when you're putting parts together in a model and when you're putting them parts together in the real world, make sure to remember where your screw holes are so that you have access to them later. You don't want that screw hole to be blind or somewhere that you can't get to it. Right now, pointing straight down, you're going to be in pretty good shape, right? There's not going to be a bunch of robot in the way. But if you take this and you turn it around so that it's pointing upward, this one you might be able to get to okay, but when you do it on the other side, there's going to be a bunch of robot in the way. So it's always good to be thinking ahead about 2 or 3 chess moves to say, you know, where do you want those screw holes to be so that you can access them easily later. Okay, so I just added that hub. I'm going to make a copy, paste. So now it's made a copy, and I'm going to attach it to the other bracket. And what you're going to see is this is just going to start going really quick because it's all just loading parts and making joints. So I'll attach that one, and we're good to go. And now I need to have an axle or a shaft. So I'm pulling a shaft. And I'll just say, okay. I'm going to grab the end of the shaft. Say do a joint. I'll pull that there, that end. And I'm going to attach it to this little spot here, like so. I'll flip it around. Looks like it's already in the right orientation. Done. And we're done. Right? I now have the shaft that's there. Any questions on that? All right, so the next part would be to model the wheel assembly. Oh, can we modify it to work with the rev flange bearing? I got a question there from Justine Thomas. Boy, if you can figure out how to make it work, I would love to see how to make it work with the flange bearing. I tried for a long time. I did not want to have to tell teams get the Amazon bearings. But I couldn't come up with a way to do it. Just the screw holes were in the way. The reason the screw holes are in the way, if we look at one of these, let me stop sharing here real quick. And if we look at this, so I created this 3D printed part. And there's some odd things about the Rev product line just because they've been evolving over time. You know, they're not, I wouldn't say they're new, but they're relatively new. So this is the mecanum wheel that they have, 75 millimeters in diameter. And if you look at the hole pattern, right, the hole pattern for the mecanum wheel is 4 holes there, and then there are 4 larger holes, but they're at 90-degree points. They're at 90-degree compass points. So there's 4 of them around that circle. And the distance from this hole to this hole happens to be 16 millimeters. 16 millimeters is really common in FTC for different components that you get. So it's 16 millimeters from that hole to that hole. Is that right? Yeah, I think that's right. Anyway, then if you look at a sprocket, then the first thing you notice is the sprocket has 6 holes. So these holes don't actually even line up, right? The 4 holes on the rev mecanum wheel don't exactly match the 6 holes on the sprocket. You can get 2 of them to line up, but that's it. You can't get any more of them to line up. So the 3D printed piece that gets created has to be a little bit smart or a little bit clever in that on one side, there's going to be 6 holes to attach the sprocket. And on the other side, there's going to be 4 holes to attach the mecanum wheel. The other thing is that when we attach these, I have an aversion to 3D printed parts on FTC robots, except in very specific circumstances. If you've ever seen my team drive, you know that they tend to run into a lot of things really fast, and that will break 3D printed parts. And so this 3D printed part that's here is actually going to be carrying, if you're not careful, it could be carrying a lot of load. And it's going to have a twisting load because when it's on the wheel, there's going to be a chain that's turning this sprocket. That sprocket has to transmit the torque through the spacer to the wheel. And if you make the spacer carry all of that load, there's a chance that it'll shear, right? And so I didn't want that to happen. And so on the spacer that's here with these two screws that are here go all the way through to the other side of the wheel where there's a nut. They're 35 millimeter screws, right? They're really long and they go all the way through through the sprocket, through the spacer to the other side of the wheel, and then are clamped on with nylock nuts. And the reason for that is so that the screws are what are actually transmitting the torque to the wheel, not the 3D printed piece, right? It's a similar sort of thing when it's on a car. Now the 3D printed piece will carry some of it, but it's really the screws that are turning the wheel with the sprocket and holding it all together. So it goes all the way through. And because those screws go all the way through this 3D printed piece, there's nowhere for a flange to go. There's not a place for the flange to go. Maybe the bearings could go on the outside. That's a possibility. There might be a ways to do it, but it was starting to get to be troublesome to get the bearings with the flanges, because it's 14 millimeters of flange, or pretty close, to be able to go and still handle the screws. So so that kind of gets to what happened. And you know, I sent the challenge to Rev Robotics, to their tech support, and said, hey, I want to do your mecanum wheels on a dead axle. How can I do that? And I asked again a couple of weeks later and a little bit later, and then they said, yeah, you're probably going to have to, you know, create your own little adapter to make it work. So I said, okay, we'll do that. All right. It is 8:30. I'm happy to continue on if there's a lot of people who want to continue on, or I can save it for another session. How many people would like to continue on? Just put it in the chat if you would, or you can say keep going for about another half hour. Joe says he has to leave. There's a question about, can I share the CAD file for the 3D printed spacer? My plan is to build all of this up from this series and then share the entire model with everybody, so that you will actually get the full Fusion model with all of the parts and everything like that that we build up in the series. I see at least I see one person leaving. It looks like a few people are leaving now. I'll tell you what, for those who want to stay, I will continue on. I'm going to talk a little bit about modeling the 3D printed piece. For those who have to leave, it's fine. It'll be in the recording, but I'll also recover it again in another session at the beginning of another session. So you could just wait till the next session. So either way works for me, and it'll give me some practice with doing the 3D modeling. So if you have to leave, that's fine. Yes, there's going to be a recording and it'll be saved for everybody. So I'm going to just start ahead on the 3D modeling part, and then I'll redo it again, and then I'll just preserve whichever one works out better. For those who are leaving, thanks for joining. There will probably be another one next week, same time, and we'll just continue with this model next time, unless another topic comes up that's more important. Okay, so now how to do the modeling of the 3D printed piece. All right, so let me get back here. So just to recap, we need a 3D printed piece. The bearings need to go inside, need to have holes on the outside where we can attach a sprocket, need to have holes on the other side where we can attach a mecanum wheel to the spacer so that it can all fit together. This is one of the things that I really like about Fusion 360. One of the things I really like is how easy it is to switch between doing assemblies and doing 3D modeling and being able to do other types of modeling that you may need to do right in the middle. So I'm going to pull up Fusion 360 again. Where's my Fusion 360? There it is. Okay, share. And we'll close that so that we're back in Fusion 360. And I'm going to start a whole new part for this. I'm not going to do it within the drivetrain. I could do it within the drivetrain, but this is a unique enough piece that it's going to be easier for me to just redesign it and then pull it in to the other ones. So, oops, not work 99 work. So for this, this is going to be my mecanum adapter. Okay, and so for this is a somewhat different way of doing the models, because now we're going to be building up a whole new part from scratch. The way to do that in Fusion 360 is by, first of all, you create things called sketches, and then you extrude them, you extend them out. So for this, I'm going to start by creating a sketch of one face of this 3D printed part. Let me switch back to that so you can see. Well, yeah, let me switch back real quick. So I'm gonna do a 3D a sketch of this, and then I'm gonna extrude it outward so that it gets the length, and then I'm gonna put the holes in on the other side and extrude it inward to cut away the parts that I need from the other side. So that's the general approach for doing this. Let me share screen to there. Share that. All right. So I'm going to start and I'm going to say, let's create a sketch. And the first thing that Fusion 360 wants to know when creating a sketch is what plane do we want to be on. So I'm going to rotate around. You see those little orange and blue plane markers. Those are denoting the different planes that are orthogonal in our model. And I'm going to say I want to do it on this bottom plane here. So it's going to be going upward. And now it gives me a top-down view of, excuse me, of the model that I've created. And if you look over in the rotation cube here, it says you're looking down at the model from the top. If I hit the little home button, it goes back to an isometric view, right, where I can scroll things around. And if I say I want to look at things from the front, it'll let me do that, and I'll be looking at the plane on edge, right? And I come back to home and go back to top. So I'm looking top down at this. And I'm going to say I want to start by creating a circle. And this is a center diameter circle. So I click on the circle, and it's going to ask me for 2 points. It wants to know, first of all, where's the center of the circle? And I'm going to put it at the origin. And now how big do I want the circle to be? And I want the circle to be 24 millimeters. So why 24 millimeters? Well, I know, looking ahead, that the sprocket I want to use is a 15-tooth sprocket. And so with a 15-tooth sprocket, it's going to go up against this little spacer. It's going to go up against the spacer here. I can't have the spacer be too big or there's no room for the chain teeth. So I've got to keep it smaller than the inner diameter of the chain. So 24 works out pretty good for that. I have to have it big enough to be able to hold all the screws. So just by measuring things out, looking up a few items, which I'll talk about in the fly set workshop, that's how I determined that it needed to be 24 millimeters. So I've got that circle there. I need another circle for the center bore. And this center bore is going to be where the shaft is going to run through. And I'm going to make that 8.5 millimeters in diameter. And I'm going to choose 8.5 because I want it to be big enough for the shaft to go in and turn freely and not hit anything else. I might have to change that 8.5 in a second. As I'm doing the dimensions on these circles, you can grab a dimension with your mouse and you can move it other places to get it out of the way to see whatever it is that you want to see. Real quickly, just to show what the next step is that we're working to get to, I'm going to go ahead and do an extrude. And the command for that in Fusion 360 is often called a push-pull operation or a press-pull. Where is it in the thing here? I only know it by pressing the Q key. Is it create? It's got to be create. No, it's not there. All right, so I'm just gonna press the Q key on my keyboard, and that starts a press-pull operation. It means we're wanting to push something in, pull something out. We're wanting to modify it in a way depending on what we click. And so now I can click this little outer circle that I want to press-pull, and you'll see that it's highlighted and giving me an arrow. And then extrusion is taking that circle and giving it length. So I can pull this away to give it some length. So by doing that, I've made this tube, this cylinder, that is there for the part of my adapter. Now the question becomes, well, how much length should it have? Well, for that, we need to do a little bit of calculation. We need to do some measurement of our mecanum wheel. So I'm going to go do a quick measurement on the mecanum wheel to find out how thick I need to make this part. So let's go to my parts folder, and I'll go into the wheel section, and I'm going to grab the right mecanum wheel. So this, I had already downloaded this from the Rev site. There's the mecanum wheel. I'm gonna, when you get the model from Rev, they have the center hub in here. I'm gonna take that off, and I can just turn off the individual pieces by hitting the little eyeballs over here on the side. So if I click on this piece, then you can see it's underlined. That's how I know which one it is. If I click the eyeball, then it hides it, so I don't have to look at it or deal with it. Same thing for this screw that's here. I can go through and say, oh, that's that one, and I can pretty well guess that it's these other ones, and now I have just the wheel left. So what I need to know is how much space do I need between this flat part of the face and to get far enough away so the chain can not hit the wheel whenever it's turning the things. That's the distance that I need. So I'm going to do a measure operation. There's a menu up here called inspect. You can do all sorts of inspections. I'm just going to do just a quick, just to show you how cool this is, I'm just going to do a quick section analysis. And so section analysis, I can take a plane and I can take it through my model and see the cross section of the model as it is in that plane, right? So I can see where all the pieces are. So that's the kind of things you can do in inspection. The inspection I want to do in this point is I just want to do a measurement, and I'm going to show snap points so I can get a specific measurement. So I want to measure from this face that's there. So I'm going to click on that little center point, and I'm going to turn to the side, and I want to measure to the tippy part of one of these little edges that are here. So I can pull around and get a good look at that edge, and I'm going to highlight the edge, and then I'm going to pull it around and grab the farthest point on that edge and click it. And when I click it, Fusion 360 comes back and says the distance from the center of that circle, which is in the plane of this face, to that point, that other point you clicked, is 34.762 millimeters. But I don't want to know the as the crow flies distance. I want to know the orthogonal distances. So if I click XYZ delta, then it gives it to me in each of the different planes. So it's 8.771 millimeters in the Z plane, and it's 27.602 millimeters in the X plane. And the real number I wanted to know is this green line that's there, which I know the numbers are hard to read, but it says 19.225 millimeters from this face to that point. So my spacer has to be at least that big, right? But I need to be a little bit bigger still because I need room for the chain itself. In FTC, we use number 25 chain, which has a width of a little over a quarter of an inch. So I'm just going to assume 8 millimeters. And so if I assume 8 millimeters for the whole width of the chain, half of that is 4 millimeters. I'll add that to the 19, add a little bit more, and I'm going to come up with 24 millimeters. Is how much space there needs to be between the face where I'm attaching one end of my spacer to the other end, which will have the sprocket. So now I can go back to the adapter, and I can go back to this extrusion, and I can edit it, and I can say, make that 24 millimeters, and now I know that it's the right size for the spacer. I'm going to pause there. Question? Any questions? Okay. We need the holes to be able to attach the sprocket. In the timeline, we have two steps. The first step is we created a sketch. The second step is that we did an extrusion. Our sketches also appear in the browser for each of the sketches we created. So if I just highlight this sketch, You can see that's the sketch I had created. It was 2 circles and the diameters that are there. I'm going to go edit that sketch and add some more pieces to it. So here we are back with that sketch, and I'm going to make sure I'm looking at it from the correct angle. So I'm going to make sure I'm looking at it from the top. So now I need the holes for the screw holes. So I'm going to create those holes for those screw holes. That's another circle. It's going to be some distance away from the center. And the screws that we're using are M3 screws. And so I just happen to know from experience that for that you want a 3.404 millimeter hole for a through hole. The way that I find that information is I can go look at one of the rev parts, and I can do another inspect operation, and I can say, measure, tell me what's the diameter of that hole. Oh, it's 3 millimeters here. Maybe I'll make it 3 millimeters even then. I'm going to go make it 3.2. I'm just going to make it 3.2. But the rev part there has a 3 millimeter hole for the screw to go through, so that's probably a good size to use. So back in my adapter model, I'm going to go through and change this to be a 3.2 millimeter hole. I'm going to make it a little bit bigger just to give the room for the screw to slide through. Now on the sprocket side, I need 6 of those holes to be able to mount the sprocket and to be able to take advantage of them. So I'm going to go ahead and put 6 holes in this. I could draw each hole individually, but it's really hard to get them spaced exactly right. So there's an important tool that I use all the time called circular pattern. And so under the create menu, I'll do circular pattern. And now I can take a set of objects or a set of items in the sketch and arrange them in a circle around something else. So I'm going to select, it's asking me, what are the objects that you want to duplicate? And where's the center point that you want it to go? And there'll be a couple of other options, and it'll create it. So I'm going to select this circle here. That's what I want to duplicate. And I'm going to say the center point, I want to go around this. And once I click the center point, you'll see it's put 3 circles in here for me. And I can even move them around. I don't know if I can move them yet, but I'll be able to move them around in a second. I want more than 3. I want 6. So I'm going to go to 4, 5, 6, and change the quantity to 6. And now you can see that this is the one I was creating, and it's duplicated it in a rotational pattern around this center point so that I have 6 of them equally spaced. And then I can say, okay, and there are my 6 holes. Now, if I move the holes, they're in blue. And the reason they're in blue is because they're not fixed to anything yet. They're still movable, right? So we want to make sure we get the distance between them correct. So my next step is to make sure that they are on a specific distance. So I'm going to say, do a dimension. That's the dimension tool. And I'm going to say, oops, I don't want it highlighted when I do that. I just hit escape for that. So do a dimension. I'm going to say the center of this hole to the center of this hole needs to be 16 millimeters. There. So now these two are fixed to be 16 millimeters apart. And because of that, that forces all of these other ones to always stay 16 millimeters apart. I can't pull them out or pull them in. Another thing that I would like to do is I would like to make sure that they're straight, aligned with each other. So there's a set of things called constraints. The very common one is horizontal vertical constraint, where you can constrain 2 items to be either in a horizontal relationship to each other or a vertical relationship to each other. So I'm going to select the horizontal vertical constraint, and I'm going to say I want this circle to be exactly horizontal with this circle. And when I do that, now they're fixed and they turn black. And when you're doing a sketch, if something is black, it means it can't be moved. It can't, it's completely constrained is the official term. And so I know that those holes are going to be in exactly the right place. So now that I've added that, I can finish my sketch. When you've done an extrusion, it automatically, it by default turns your sketch off because it assumes you draw a sketch, you extrude it, and you're done. I'm going to turn it back on and come around here. This is where my item is. And I'm going to make another extrusion part. I'm going to do, where's the press pull option? I can't believe I can't find it. Is it this one? No. Is it this one? There it is. Okay, it's under modify. So press pull, I'm going to do a press pull operation, and I want to do a press pull on that circle, that circle, that circle, that circle, that circle, and that circle. If I pull away from the front face, it says, aha, you're wanting to create pegs. If I pull into the face, it says, aha, you're wanting to create holes. Right? And it kind of knows that by default. You can force it to be one or the other. Like you can force it to be a join, a cut, an intersect. You can force it to do other things. I'm wanting it to do a cut. And so what it's doing is actually cutting holes into this piece. And I'm going to make it go into the piece 8 millimeters because the screws I'm going to be using could be 8 millimeters long. But I only want to do it actually for 4 of the holes. I don't want to do it for that hole and that hole because I'm going to need 2 holes that go all the way through the piece. So I'm just going to do it for those 4 holes there. All right, and now I can do another press pull, and I'm going to do these 2 circles that I didn't do yet, and I'm going to go all the way to the other side so that I have holes going all the way through the piece. So that's looking pretty good, right? So now, and I can turn this sketch back off real quick. That's looking pretty good. So here I have my 2 all the way through holes, and I have my 4 other holes where I can use that I'll be able to use to mount the screws. Now these are through holes, right? And we want these to be able to grab screws. So we want them to be threaded. So really quickly, just because I think this is so cool that Fusion 360 will do this, I'm going to go to the Create menu, and I'm going to say, please thread these holes. There's a thread option here. So I'm going to do a thread option, and I can go pick those 4 holes that are not all the way through. So I'm going to pick those 4 holes, and I can come over here to the thread thing, and it's it looked and saw the holes, and it says, oh, they're about 3 millimeters big, so you probably want an M3 screw. So I'm going to assume that it's an M3 screw. Now I can choose a different size of hole that I want to do for metric, and even if I knew I wasn't going to be using metric screws, then I can go to ANSI United States screws. Whatever they be, but they are going to be metric screws. So I'll go through and say, make those M3 screws, model those, don't just make them look like threads, but really put threads on them and say, okay. And now if I go look at my model, you'll see that my 3D printed part is actually going to have the threads to hold the screws in place. So that now when we go to attach the sprocket, if we want to use these holes, we can screw directly into the 3D printed piece and we don't have to have a nut on the other side. To me, that's just like really cool. All right, the last thing that we need on this is we need a place for the bearing. So I'm going to go back for the bearing to fit in. So I'm going to turn on this sketch again. I'm going to edit this sketch. I need 1 more circle for the bearing to go in. So I'm going to go say, give me a circle. It's centered on this one. And this one needs to be 12.3 millimeters. Like so. The reason for 12.3 millimeters, the outer dimension of the bearings is 12 millimeters, and I can measure it with a caliper and it'll come pretty close. But when we print with a 3D printer, it's not going to be precisely 12.3, and so if I model it as exactly 12, the hole that we're going to get is going to be too tight to press the bearing in very well. And so usually you want to add about 1/10 or 2/10 or 3/10 of a millimeter for the parts to fit together as a press fit. Typically 1/10 is considered very tight fit. 2/10 is considered, you know, a snug fit, and 3/10 is kind of a loose fit, but it's still snug enough. So I'm just going to do 12.3 here for that that hole. I'll finish the sketch. Once again, we'll do a press pull operation. I'm going to grab that 1 circle that represents that, and I know the depth of the bearing is 3.5 millimeters, and now I have an inset point where the bearing can go. If I turn off the sketch, we're in pretty good shape there. So there's the 3D printed part on that one side. I just need to create the holes on the other side. Actually, I don't even need them if I'm not going to screw them in. So I could just create the hole on this other side. Let's go ahead and do this other side really quickly. Anybody have any questions so far? Anybody need me to pause or anything? Okay. So I'm going to go back this time because we're going to want to cut into the other side. We have to make a new sketch, right? So I'm going to say create a new sketch. And once again, it's asking me what plane do I want the sketch on. I actually want this new sketch to be right on this end of this extrusion of this spacer. So you can select that actual plane. Like I can literally just select this plane and that becomes my sketch plane. And it already knows the shape that's there. It's already put a circle here that represents the inner bore and it's put the outer circle there. So it's already created a default sketch for me that is the shape of this flat surface of this piece. So I need another pair of holes that will be used to hold the screws. So I'm going to go through and say, put a hole here for me, please. Let's do a constraint. There's an equal constraint when you want to make sure that two things are the same size. So I want this hole or this circle to be the same size as that circle. So I put those together and say make them equal. You'll see that it's put these little equal bars on these two parts to indicate that they are equal in size. And I'm going to go through and do the same thing I did before with the circular pattern here. And I'm going to say take this circle and repeat it around the center point. Do it 2 times so they'll be 180 degrees from each other. And say, okay, that's okay. And so it did that. I'm going to make sure they are 16 millimeters apart. Actually, I'm going to make sure they're above each other. I'm going to make sure they're vertically connected, like so. So this little marker that's there says that this center of this circle is vertically constrained with this one. And now I can do the distance and say, make sure the distance between these two is 16 millimeters. Ha, I got it right before, and now they're that way. I need a 12.3 millimeter circle for the bearing that goes on the other side. So 12.3, like so. And you can see just how close things are in this bearing, right? I mean, putting the bearing there, even without a flange, we're getting really close to those screw holes, right? And now we're going to do a couple of press pulls. So I'm going to say press pull. Oh, it doesn't show up on this one. Okay, so I'm going to finish my sketch. And now I'll do a press pull these two circles. And I'm going to go in by 8 millimeters. So I can type in -8. And that says go in a depth of 8 millimeters. And I'm going to turn that sketch back on. And I'll press pull this one and say go in by -3.5 millimeters. And that is there. And now let's add the threads in those two holes. Actually, I don't have to add it. I'll add a new set of threads. It's what most people would almost certainly do. But I'll just select this hole and say model it and do it that way. And now those are threaded holes instead of just being through holes. And we're pretty close to done. I'm going to go ahead and save this at this point. I'm also going to change the appearance just because I can. For this one, to make it look really cool, it's going to be metal, and of course it's going to be gold. So now I have a gold spacer. Let me save that as well. Let's turn off the sketch. And so there I pretty much have the spacer created. Now there's a few things we haven't handled yet, and I'll cover those when I do it again this way, but that gives you the general idea of how to use the spacer. And so now when we go back to our drivetrain and we start pulling in a mecanum wheel, well, let's make a new component for it. Actually, we'll just stop in this component, which I'll explain that a little bit later. But I'm going to create a new component. And this is going to be the wheel assembly. I'm going to pull in a left mecanum wheel into that. And I'm going to pull in my spacer, my rev mech adapter. And now we could start doing the standard things that we would typically do, joining those together, adding the sprocket, making it all into one piece. But I'm going to stop there and come back to this for next time. Any other questions? Anything else that anybody else would like to see or hear about before I go along? Okay, well, I'm not hearing anything, so either you're muted or whatever. It's almost 9 o'clock, so I think that's a good point to start. I'm going to try and keep these from going too long. Thank you all for joining. I will post the video when it's done, and we will have another follow-up session at some point where we'll pick up with the 3D printed piece that was done and put in the sprockets and the motors and talk about some of those for continuing this on. But I think you're able to see kind of the point of today's session was really you're able to see how you can use Fusion 360 to take all of the robot parts, put them together, attach them, deal with things in terms of rotations and you know, get the joints right, get the measurements right. It doesn't take too long to learn, and it really helps to see an example like this one, I think, because now you kind of know what you want to look for and what the steps are going to be. Everybody have a good weekend. Thanks so much for joining. We will see you again next time.
Thank you, Patrick, if you didn't hear me.
Oh, no, I didn't, but thank you. I'm glad to hear the thanks. Glad you were able to join.
I had a few other people in the region that said they were going to join in today, but they didn't make it. So
well, that's okay. It's recorded. Tell them to come to the next one. You get to see more of the same.
Where are we going to find the recordings at? Have you figured that out?
I haven't decided. It's almost certainly going to be on YouTube. But what will happen is I'm going to post them on my YouTube channel, and then as I send out each link, I'll have the links to the previous recordings, or at least to the section in YouTube that has them.
Okay, sounds good.
I looked at the other one. I'm still editing the other one a little bit, and I'm not sure that I feel comfortable about showing everybody's faces publicly yet. This one I didn't. The way I recorded it last time wasn't exactly the best. This one I think I got better. I'm learning.
Right.
I will still share. Yeah, I will still share the other recorder. I've just got to do a couple of cleanups.
Okay.
All righty.
Well,
take it easy.
I'm going to use them with my kids in class to teach it.
Cool. Fantastic.
So, anyways.
All right. We'll see you next time, Don.
All right. Thank you, sir.